Hello, everyone. Welcome to this video on learning mathematics through concepts and examples. Today, we are going to work on some examples problem from the derivative of the function. And here we are going to learn how to calculate the derivative of function using rules and formulas. Okay, let's get started. So here is our first example. First two examples, I would say. So let's see, the first function is f of x equal to, let me write it down. Okay, so here we have f of x equal to square root of x plus x cubed plus pi. So we want to find the derivative f prime x. The derivative of square root of x is 1 over 2 square root of x plus the derivative of x cubed. If we use the power rule, we bring that 3 in front and then we reduce the power of x by 1. So that will be 3x squared. And then derivative of pi is 0 because pi is a constant. So the derivative is 0. So the derivative of that given function is 1 over 2 square root of x plus 3x squared. Okay, let's look at the second example. In this one, you have f of x equal to, f of t equal to, here the variable is t, equal to t squared plus 2t cubed multiplied to e raised to t. So because we have the product of two functions, we can use the product rule here. So the product rule says the derivative f prime t is equal to first function, which is t squared plus 2t cubed, multiplied by the derivative of second. Derivative of this second function is e to the t, because derivative of e to the t is e to the t, plus second function e to the t multiplied with the derivative of first. So the derivative of this first function, derivative of t squared is 2t, and then derivative of 2t cubed is 6t squared. 6t squared using that power rule. Now you can see in these two terms, we have e to the t common. So we can factor that e to the t out. Then we get t squared plus 2t cubed, then plus 2t plus 6t squared. We can simplify that a little bit, e to the t. So the highest power of t here is t to the third. So that is the first one we can write, 2t cubed. Then we go to t squared. Here is a t squared plus 6t squared. That is a 7t squared. 7t squared. And then we go to t. We just have plus 2t. So plus 2t. So that is the derivative of that second problem. Okay, let's move on to next one. So here we have g of x equal to x squared plus 1 natural log x. We have to find the derivative of that. So here also you can see that this is the product, x squared plus 1 multiplied to log x. So our function here is g of x equal to x squared plus 1 multiplied to natural log x. Because it is the product, we can use the product rule. The product rule says first function, x squared plus 1, times the derivative of second. The derivative of natural log x is 1 over x, plus the second function, which is natural log x, multiplied to the first one, the derivative of the first. The derivative of x squared plus 1 is 2x, multiplied to 2x. We can simplify this a little bit, not much. So this one here is x squared plus 1 multiplied to 1 over x. So if we multiply or if we distribute 1 over x times x squared, that is x, plus 1 over x times 1, that is 1 over x. Then plus, here we have 2x times natural log x. 2x times natural log x. That's it. That is all we can simplify. So we can leave it here. So that is the derivative of that given function. Okay, next one involved the trig functions, the product. So let's see how we can do that. We have y equal to y equal to tangent x multiplied to secant x. So the derivative dy over dx is equal to, okay, let's use the product rule. Product rule says first function, which is tangent x, times the derivative of second. Derivative of secant x is secant x tangent x. Secant x tangent x plus second function secant x times the derivative of first. Derivative of tangent is secant squared. So what we get here is, you can see, we have secant x tangent squared x, secant x times tangent squared x plus secant cubed x. If we want, we can factor that secant x out, and we get tangent squared x plus secant squared x. So that is the derivative of that given function. Okay, let's move on to next pair. Here we have to find the derivative of the function given below. So here is that function. And you can see that this function has a numerator and denominator. That means we are dividing one function by the other. So here we are definitely going to use the quotient rule. So let's do that. So we have y equal to 2x squared plus x over x cubed minus 1. So if we use the quotient rule, dy over dx is equal to, the quotient rule says a denominator, which is x cubed minus 1, times the derivative of numerator. Derivative of numerator will be, derivative of 2x squared will be 4x, and the derivative of x will be 1. So that will be 4x plus 1. Then minus numerator, which is 2x squared plus x, times the derivative of denominator. Derivative of x cubed minus 1 is 3x squared. 3x squared. Everything divided by x cubed minus 1 quantity squared. So we use the formula. Now we need to simplify the numerator and make it little clean. So what we can do is, over here we can FOIL. So x cubed multiplied to 4x will be 4x to the 4. X cubed multiplied to 1 will be x cubed. Then if we multiply there, that will be minus 4x and then minus 1. Similarly, if we distribute this here, if I multiply there, that's going to be 6x to the 4, but there's a minus in front. So minus 6x to the 4. And then if I multiply here, it will be 3x cubed, but there's a minus in front. So minus 3x cubed over x cubed minus 1 quantity squared. Now we can combine the like terms and write our final answer. So we go to the fourth power here. We have negative 6x to the 4 and positive 4x to the 4. So that's like 4 minus 6, which is a negative 2. So negative 2x to the 4. Okay, after the fourth power, the next one we have is the third power. So we have 1x cubed minus 3x cubed. So it is like 1 minus 3, which is a negative 2. So negative 2x cubed. Negative 2x cubed. After x cubed, we have x, which is only 1, minus 4x, and then minus 1. Minus 4x, and then minus 1. Everything divided by x cubed minus 1 quantity squared. So that's all we can simplify. So you can leave it there. That is the derivative of this function. So here we use the quotient rule to find the derivative. Okay, wonderful. Here's the other one, a trig function in the form of numerator over denominator. So here also, we are going to use the quotient rule and simplify this. So let's do it. So here, our function is y equal to 1 plus sine x over 1 minus sine x. So if we use the quotient rule says denominator, which is 1 minus sine x, times the derivative of numerator. Derivative of this numerator is cosine x. So we multiply that by cosine x, then minus the numerator, 1 plus sine x, times the derivative of denominator. Derivative of denominator will be negative cosine x. 1 minus sine x quantity squared. So now we can again distribute here. So cosine x multiplied to 1, cosine x, then cosine x multiplied with sine x, and there is a minus. So minus sine x cosine x. Then over here, if you multiply, that will be minus cosine x, and there is a negative in front. So that will be positive cosine x. Positive cosine x. And again, when you multiply here, cosine x times sine x, so it will be negative sine x cosine x with a negative in front. So that will be positive sine x cosine x. And we divide all that by the square of the denominator. In this case, we already have that 1 minus sine x squared. And if you look at the numerator, two terms have opposite sign and they get cancelled. And we are left with, in the numerator, cosine x plus cosine x, 2 cosine x, and in the denominator, 1 minus sine x quantity squared. So that's how we can use the quotient rule to find the derivative of trig function, which is given here. Okay, let's move on. Here comes the next one, is the combination of trig function and also the algebraic function. So let's see how we can find the derivative. So we have two questions here. We have to find the derivative of those two problems. First one is f of x equal to, let's write it down. Okay, here our function is f of x equal to cosine 2x plus 5, then plus 4x squared. So the derivative f prime x will be, to find the derivative of the first term here, that is a composite function. So what we do is we use the chain rule. Chain rule says we have to find the derivative of the outside part first. So the derivative of cosine will be negative sine, keeping the inside same. So that will be negative sine 2x plus 5. And you multiply that by the derivative of inside function. So in this case, the derivative of inside function, derivative of 2x plus 5 is a 2. Then plus, we have to find the derivative of this one, derivative of 4x squared. We can use the power rule. So 4 times 2 is 8, and you reduce the power of x by 1, so 8x. So finally, we can simplify this as, so when you multiply this one with 2, we can write that as negative 2 sine 2x plus 5, and then plus 8x. So that is the derivative of that first function. Now, let's look at the second one. G of x equal to tangent of x squared plus 1. Let's see how we can do that. So here we have g of x equal to tangent of x squared plus 1. So you can see that this is a composite function. The outside function is the tangent function, and the inside function is x squared plus 1. So we use the chain rule, g prime x equal to the derivative of outside function, keeping the inside same. Derivative of tangent is secant squared. Keep the inside same. Then multiply by the derivative of inside function. Derivative of x squared plus 1 is 2x. So you can simplify and write like this. G prime x is equal to 2x times secant squared x squared plus 1. Okay, few more to go. Here we have a trig function, a sine function and inverse sine function. Let's see how we can find the derivative of each of these. And both of them are composite function, by the way, so we have to use the chain rule. The first one is y equal to sine square root of x plus 2. Outside function is sine x, inside function is square root of x plus 2. Composite function, we use the chain rule. So dy over dx equal to, chain rule says first find the derivative outside, keeping the inside same. So the derivative of sine is cosine. So it will be cosine square root of x plus 2. Then we multiply by the derivative of inside function. If we want to find the derivative of inside function, derivative of 2 is 0. Derivative of square root function is 1 over 2 root x. So we can multiply those two. Cosine square root of x plus 2 times 1 is cosine of square root of x plus 2. Everything divided by, because cosine, this is same as cosine over 1. So 1 times 2 root x is 2 root x. Or that denominator will remain as it is. So that is the answer for that. Now let's go to the second one. Inverse function here. So let's see how we can handle that. So here we have y equal to sine inverse 2x squared plus 4. So this is also the composite function. So we use the chain rule. So first, dy over dx is equal to the derivative of outside function, keeping the inside same. The derivative of sine inverse is 1 over the square root of 1 minus x squared. So it is like 1 over the square root of 1 minus x squared. But in place of x, we have 2x squared plus 4 because we keep the inside same in chain rule. Like that. And we multiply by the derivative of inside function. So derivative of 2x squared plus 4 is a 8x. I mean, is it 4x? 2x squared plus 4 because 2 times 2 is 4. So that's a 4x. Now we can simplify that. Dy over dx is equal to, if we multiply here, 1 times 4x is 4x. And in the denominator, we have the square root of 1 minus, if we FOIL this, 2x squared plus 4 is squared. So that is 2x squared plus 4 times 2x squared plus 4. If you FOIL that, you get 4x to the 4 plus 16x squared plus 16. That is when you FOIL it. Now if you simplify, let's see what you get. Dy over dx equal to 4x over the square root of, look here, we have a 1 and we are subtracting a 16. So 1 minus 16 is a negative 15. Then when you distribute this negative here, minus 16x squared. And also when you distribute this negative here, minus 4x squared. So that is the derivative of that given function. Okay, so we got that. Wonderful. Let's look at next pair of functions again. So this one involved inverse tangent and the logarithmic function. One more time, both of them are composite function. So chain rule is still working here. Look at the first one. We have y equal to tangent inverse 5x plus 3. So the derivative is dy over dx. So in chain rule, we first find the derivative of outside function. Derivative of tangent inverse is 1 over 1 plus x squared. So we write that as 1 over 1 plus, in place of x, we have 5x plus 3 because in chain rule, we keep that inside function as it is when you do the derivative of the outside, and we multiply by the derivative of inside. The derivative of 5x plus 3 is a 3. So what we get is dy over dx is equal to 3 in the numerator. In the denominator, 1 plus. Now if we FOIL this, 5x plus 3 squared, 5x plus 3 times 5x plus 3 is 25x squared plus 30x plus 9. Then that can be simplified as, we can simplify the denominator. So 3 in the Numerator in the denominator, 1 plus 9 is 10, plus we have a 30x and 25x squared. That's it. That's how we can do it. Okay, so that's the first one. We got the derivative of inverse trig function, inverse tangent function here, which is in the form of composite function using the rule and formula. We use the chain rule and we use the formula for tangent inverse. The derivative of tangent inverse is 1 over 1 plus x squared. Okay, here is the next one. H of t, a log function. H of t is equal to the natural log of square root of t plus 2t squared. So this is also the composite function. The outside function is the natural log function, and the inside function is this one. So we use the chain rule, h prime t equal to derivative of natural log is 1 over that argument, which is 1 over the square root of t plus 2t squared, and you multiply that by the derivative of the inside function. Derivative of the square root of t is 1 over 2 root t, then plus the derivative of 2t squared is 4t. 4t. We can simplify this a little bit. First fraction, I'm going to write as it is, 1 over square root of t plus 2t squared. For the second function, the LCD will be 2 square root of t. For if I want to combine these two, the least common denominator will be 2 square root of t. And then if we try to simplify and get the numerator will be 1 plus 8 t raised to 3/2 or t raised to 1.5, like that. Now, what do? We have two fractions in the form of multiplication. So we multiply numerator with numerator. So 1 multiplied to that, just that one, which is equal to 1 plus 8 t raised to 3/2. And in the denominator, we multiplied this one with this. So 2 square root of t multiplied to square root of t is 2t. Then plus, if we multiply here, this one with this. So 2 times 2 is 4. And then square root of t times t squared is t to the 3/2. So that is the answer for the second part here. So in both of these, we use the chain rule. But the formulas we use are different. For the first one, to find the derivative of tangent inverse, we use derivative of tangent inverse as 1 over 1 plus x squared. Whereas in the second one, the derivative of natural log x, the formula, okay, the derivative of natural log is 1 over the argument. Argument is this one, so 1 over that. And we use the chain rule and multiply by the derivative of inside function there. Okay, let's look at the last set now for this video. Okay, so here we have in the first one, f of x equal to e raised to x plus sine x. So this is also the composite function. Your outside function is the exponential function. Inside function is x plus sine x. So the derivative can be calculated using the chain rule. So derivative of outside function is e to the x, but we are keeping the inside same. So e to the x plus sine x. And we multiply by the derivative of inside function. Derivative of x is 1, and derivative of sine x is cosine x. And you can see that there is nothing we can simplify after this. So that is the answer for this one. Okay, now let's work on the last example for this video. So here we have y equal to sine of cosine of natural log x. This is also the composite function, but combination of three functions. The outermost function is the sine, then the middle function is cosine, then natural log. So how we use chain rule, let's see. So dy over dx, the derivative is equal to, if you use the chain rule, first you do the derivative of outside function, the outermost function, keeping everything inside same. So derivative of sine is cosine. So we write cosine of inside function same, cosine natural log x. Cosine of cosine natural log x. Then we multiply by the derivative of inside function. Let me write it down. Derivative of cosine natural log x. Now let's see how we can find this one. So the first part will remain the same, which is cosine natural log x. Now the derivative of cosine, this is also the composite function. So derivative of cosine is negative sign, right? The derivative of cosine is negative sign. So we write negative sine natural log x. And then we multiply by the derivative of inside function. Derivative of natural log x is 1 over x. So we multiply that by 1 over x at the end. Then you can see that the first term is positive, second is negative, third is positive. So if you multiply all that, it will be negative, and then cosine natural log x multiplied with sine natural log x, all divided by x. That is the final answer for this one. So even if you have more than one function in the form of composition, you are still using the chain rule, but you have to, in this case, you can see that we have to use the chain rule 2 times because there are 2 inside functions. So if there are 3 inside functions, you have to use the chain rule 3 times and so on. Okay, that is all in this video. I hope you find this video helpful, and thank you so much for watching.